I introduced the topic yesterday, today I want us to look at the water cycle. We can read this, right? Now, some of us may be wondering, where is the water coming from that we drink from our taps in the house? Some people here know that water just comes from the tap, right? I asked someone last time, where do you get your water from? And said, from the tap, man. Now, in fact, before water gets into your tap, it travels through some journeys, some environmental journeys before it gets to your house, all right? So today I want us to focus on those things, that the journey through which water travels before it can get to the house, where you drink or where you take your bath and all that, okay? Now, there are some key words, therefore, that I want us to do, that I want us to be able to define after this session, okay? And then, let me just help you okay, I want to start from the top. Now, I want to put down the screen so that everyone can be able to see clearly what is happening here. All right. So, the water cycle, if you read from the bottom, it says there, from the ground to the atmosphere and back, right? Which means this is the journey that the water is going to take from the ground to the atmosphere and then back again into the ground, all right? Now, I want us to start looking at, let's start off by defining what water is. Mabasa, can you read quickly over this?
Water is a transparent, tasteless, odorless, and colorless fluid which is important for life on Earth.
Do we agree with this definition? Yes. It's like that. It is tasteless, it is odorless, but it is a very important substance. Can we live one day without water? No. I wouldn't survive one day without water. So we need to understand therefore where the water comes from and why or how it ends up in our taps, right? Let's begin there. If you imagine water, this is what you imagine, right? This is what we imagine when we think of water, right? And then any other form by which water can be or in which water can be is very, not understood by many people, right? Now, for instance, water can change states. Do we know that?
Yes.
Give me some of those states in which water can be. Yes. Solid. Water can be solid, right? It can be pure. It can be gaseous. That is the part where I want us to start. How does water turn from the other state into a gaseous state? What happens? Evaporation. She has said one of the key words. She says evaporation. Evaporation has to happen in order for water to change its state from being liquid or solid into gases. That is true, right? We agree. Right. So I want us then to go through this process. Have we ever seen of this before? Yes. What do we call this? The water cycle, like I've already mentioned. Okay. So someone has just said that you have to start from the water has to evaporate first, right? And then when it evaporates, it has to get to another state. That is the gaseous. And then from there, what happens? Who can guess what happens after that? Say what? Condensation. What is happening here? That is what? What is this, by the way, by name? It is a cloud, right? Now, which means water has to then turn from being gaseous. When it's gaseous, can we see it with our eyes? We can't. Which means that it has to change again in order for us to be able to see that now it is changing into something else, and definitely after that process is done, it must be able to come back to the state which we then are able to use in our houses. Like what? The liquid state. right? We agree on that part. Now, I want us to quickly go through this process here. We said that there is first what? Evaporation, right? And then evaporation, why is the arrow pointing upwards? Mabasa?
Because when the liquid is heated, the density reduces and so and then it comes.
Give him a high five. Yes, because when air is heated, or when water is heated up, right, and it changes into that gaseous state, and it becomes lighter. So it has a tendency, therefore, of doing what? Of rising into the atmosphere because it's warm and light. Now, when it gets into the atmosphere, have you ever heard of the saying? Is it a saying where they say the higher you go, what happens? The colder it gets, which means as it rises up into the atmosphere, then it gets colder, right? And then that is when the issue of condensation then comes in, and then we start seeing what? Clouds. Because that is the position now in which the water is starting to turn into a liquid again from the gaseous state. Do we get that part? And then if this process is very intense, right? If it's so intense, those tiny droplets, because clouds are actually what? Tiny droplets, very minute droplets, right? But if the process continues and the cloud gets colder and colder, then the droplets get what? They collide with each other and they get bigger, right? And when they get bigger, what happens? They will be heavy enough to be pulled by the force of gravity. Yes. Then gravity takes over. We know that we can't fly because we are heavy, right? The same thing applies. When the droplets are heavy enough to be pulled down by the force of gravity, that is when they start doing what? Falling into the surface again, right? And then this is when we start saying now it is what? It is. We have seen the clouds, right? And then we say it is raining. This is what we carry our umbrellas, right? Because now it is what? It's raining. The water is coming back. This is the very same water that was on the ground, which escaped through evaporation. And then it condensed. And then now it's raining back, right? And then we start carrying our umbrellas. Rain. By the way, we are happy with what? With rain, because we know that water in our taps is what we'll be able to take a bath, we'll be able to cook, we'll be able to wash, right? So this is a very important substance. So when it rains like this, it may be bad for you when you're outside, but still we are enjoying the rain because that is life for us, isn't it? Yes. It is. And then from there, when it rains, the big question, it is coming back now into the surface. Where does the water go when it lands on the surface? That is the part that we also need to understand. Where does the water go? Was it not raining yesterday? It was raining, cats and dogs, right? But do we have water outside? Where did the water go? Did it all evaporate? Where did the water go? That's the part I want to hear now. Sandra. It went to the dam. Woo! That is great. It went into the dam, some of it went into plants, right? The plants are using the same water to grow. Yes, Sukati. It was absorbed, some of it was absorbed by the ground. It seeped into the ground. Now, this is the part where I want us to go through. Now, you see the gaps that I left there. It says, the first one says it falls on what? Trees. Onto trees. Now, when the water lands on the surface, some of it falls onto trees, right? The trees are playing a role. Not that when it falls into trees, that is where the tree is able to use the water, no. But when it lands on the tree, that process is called interception. Why interception? Who understands the word interception? When you intersect something, what is it that you really do? Say what? like blocking the water from going down to the ground. That is what exactly is interception, right? That is exactly what happens. Such that when it starts raining, you can actually try to get shade under a tree, because you understand that the leaves are actually protecting you from most of the drops for a moment, before then they start also falling into the ground. We call that process what? Interception. That is one of the key words that we need to understand today. And then the second one is saying, some of the water does what? Seeps into the ground as what? As groundwater. I know some of us at home do have what we call boreholes, don't we? Yes. We have boreholes at home. Where does the water come from? From that borehole. It comes from underground. Now, which means the same rainwater that we're talking about is seeping into the ground and is stored underground as an underground water store. Now, we call these underground water stores aquifers. I mean, maybe that is a bigger word for now, but we just call them underground water. But we call those stores aquifers, right? This is why we are able then at home, when we need water and our parents have some money to use the drill to get that water, then the water just comes out. We could be asking ourselves, why? Why is there water there? It's because the water has been stored there for some time. As the rain comes, some of the water from the rain seeps into the ground and is stored into some permeable rocks. We call them permeable rocks. Why permeable? It means they are able to draw the water and store the water in them, right? That is a concept maybe that we can learn more next year when we get to Form 2. And then the last point is saying some of the water flows on the ground surface into rivers, lakes, and oceans. That is why there is so much water in the oceans, because the oceans are replenished by the rivers coming from all over the continents. All the rivers are flowing into the oceans, right? So the oceans will never dry out, definitely, right? So that is what happens. Now, before it starts seeping into the rivers and lakes, have you noticed that when it rains, it's like you need long boots like this outside, right? Because the water is flowing on the surface outside, right? It's busy flowing here. You can't move because your shoes are going to be wet, right? Now, that is another process that we need to understand. We call that overland flow. The water is just flowing on the land. It collects and flows on the land before it finds its way into the stream. Now, right outside here, there is a what? There's a small drain that drains the water from around the school. Have you noticed that? When it rains hard, this drain here is full of water, right? And then the water is flowing into the nearest stream down there, and then it will join the Babane River, and then the Babane River will join the Usuchwana River, and then all the way into the big Usutu, right? All the way into Mozambique. Now, this is a process that starts from here at school. You see things flowing around here, and then it starts finding its way into the nearest stream. We call that overland flow. The name is what? It's self-explanatory, isn't it? It is flowing on the land, right? That is what I like about this, because it is self-explanatory. And then from there, we see that from the above processes that we have just mentioned, the water can be used by us humans, right? And then animals and also the plants, right? And then at the same time, some of the water can evaporate to start the process all over again. Give yourself a round. All right. Now, is that a question? Yes.
And I was asking, what happens to the water that flows on the highway?
On the highway. Do you realize that the highway is actually drained? It has drains. The engineers, when they designed the roads, they make sure that whenever it rains, the water should not remain on the highway, because that will be dangerous to drivers. In what way? Because it will make puddles. Puddles are what? Are very dangerous. Those small, lakes that you find along the road, those can actually, lead to what? To accidents. I can attest to that. My own dad almost died from something like that. When my brother was driving, he wasn't aware that this was a party because it was at night. And then he sped into the party, and then the car was forced off the road, and it hit a tree. Now, those are very dangerous things. So the engineers know that they need to make sure that there are drains. When the water is flowing, they make sure that the relief of that area, make sure that the road is not collecting, but it allows the water to drain off the surface of the road into the drains on the side, and then it is allowed to seep into the bigger drains that take the water into rivers. You get something like that? That is exactly what happens. So you will not find if the highway is flooding, it means that those engineers did not do a good job. That is the problem, right? Now, so I have a short exercise for us. Can you take one and pass to the back? This one is just going to help us to remember some of the big words that we have learned today. Some of the words, I want to see if people were listening. I know we are good listeners, so I just want to be sure that it is happening indeed, that people were all listening. Please take one and pass to the back. Okay? And then, the first one, I'll just do one with us. Yes, Miss? Okay, all right. Okay, that's okay. The first one, I just want to see if people were here today. Water can what? From lakes, rivers, and oceans? Miss Mena? Water can evaporate. Woo! Yes. Now, excellent. So can we just finish off this exercise before the bell rings, please? Because it's a short exercise. Do you agree? It is a short exercise. So can we just do that quickly? All right. Now, the slide here is just meant, I made this one just to remind you of the whole exercise. So, as you can see, there are the big words here. There is evaporation, right? Or it starts way up from the sun, hitting the ground, leading to evaporation, and they have, try to explain each one of these and where the water goes when it lands on the surface, because that is the major purpose of the exercise. Can we quickly write that one? Where is your pen, miss? I can give you mine. All right, can we make this fast so that by the time the bell rings, it's all good?